We are in a discussion of AWS solutions architect, and under the solution architect discussion, we've been discussing about storage solutions provided by AWS. Under that, we discussed S3 buckets, EBS, Elastic Block Store, and then we discussed EFS, Elastic File System, and then we discussed the previous video about FSX and Last file system. So now we are moving to a new topic, which is called Amazon Elastic Container Service, ECS, right? Under Elastic Container Service, we're going to discuss about how Elastic Container Service is important in service aspect, and then first we're going to discuss a generalized idea of what a container is, and then we're going to discuss related to the service provided by AWS, which is ECS. Also, we're going to talk about EKS, Elastic Kubernetes Service, as well in a separate video, but in a comparison, we're going to talk about a little bit of EKS as well in this video, right? All right, let's get it started. Okay, so the first thing I'm going to looking into that is why the containerization matters. The evaluation from a virtual machine to a containers, right? So how do we went from physical server to virtual machines and virtual machines to containers, right? So we'll quickly look into evaluation timeline. So initially in 1990s, 2000 age, we've been using traditional servers in our premises. So one application for physical server. So we've been running services in our on-premises physical server, one application in a one physical server. Maybe you're running a web server in a one machine, you're running a application server in a second machine, like accounting application, and then you're running in a database in another machine and connecting database with the application server, right? Or you could run two applications in a one server, like you running backend database and front end machine, and then you uh, install client application in the client computers, and then through the client application you connect into the server, or you use remote desktop to connect into that server. So something like that. So that is our traditional service method. So one application per physical server, and then we moved into virtual machines. So VMware, uh, Hyper-V, Oracle VirtualBox, right? So these sort of things got a bare metal servers. Some of them like VMware hypervisor type 1 and hypervisor type 2 is a hypervisor running like Windows operating server operating system. On top of that, something similar to that. So that is multiple virtual machines sharing a physical hardware. So let's say you have a machine with a powerful CPU, more CPU cores, and then you have memory, right, like 96 memory or something. So you possibly can run three virtual machines on top of that machine, right? So that virtual machines are sharing the hardware, like memory, CPU, and all other resources like networks and other stuff in that server. So that is multiple VMs sharing hardware. And then it's coming into container age. So containers, multiple containers sharing OS kernel. So that's one OS and so many containers on top of that. But when you look into virtual machines, there are different guest OS system running in each different VM in particular virtual server, sorry, particular physical server. So what is the difference between these containers? So they are lightweight and fast, minimal overhead. You can deploy rapidly. It's quicker than you deploy in a virtual machine. So consistency across the environment. So it doesn't depend on OS. So better resource usage, maximum hardware efficiency, and easy scaling. So we can scale easily with these ones. So let's looking into VM virtual machines versus container architecture. So you can better understanding, right? So in left, you can see virtual machines architecture, and then you can see right in the container architecture. So the bottom is similar. So you have hardware, CPU, memory, and storage. So both of them are similar. Then virtual machine, you got a hypervisor, type 1 or type 2. So you can use like a VMware, sorry, bare metal, sorry, bare metal. You can install hypervisor on a bare metal hardware, or you can use something like hypervisor type 2, like Windows server operating system on top of physical hardware, and then you can make like a failover cluster environment, Hyper-V, and then you can run virtual machine on top of that, like VMware VirtualBox are some of the examples for that. And then that layer in a container is host operating system, so Linux, right? And then third layer, so you got a different virtual machines. Each one is a guest OS 1, guest OS 2, guest OS 3. They can be different operating system, Windows, Linux, Ubuntu, anything like that, right? And then on top of that operating system, full operating system, then you can run applications like F1, F2, F3. Here in after host operating system, so you use containerized Docker, containerized runtime. So runtime has libraries and everything, right? And it runs in application libraries. So container 1, container 2, and container 3. So they're running as a different. So the different is each OVM has full OS, higher resource overhead in that physical machine. Here the shared OS kernel. So operating systems kernel is shared with among these containers. So it's a lightweight and efficient. So that is basically the major difference between a virtual machine and the container, right? All right. So we'll before we going into that picture, we're going to talk about container orchestration. So managing container at scale. So when you have a container, so what does this orchestration do? Orchestration is automating deployment, management, scaling, and networking of containers across distributed systems. So when you have a container, so you know with the container, now containers managing this container with a distributed system. It's like a cluster. It's a bunch of containers. How do you do manage and maintain it is what we call orchestration. So orchestration automates deployment, management, scaling, and networking of containers across distributed systems. So once you configure, they automatically work like scaling and managing, right? So if you have unhealthy one, it will restart or might get another instance running. So something like that, right? And then how do you do networking? So how do you connect the all you can orchestrate? So what is the benefit of orchestration? So uh, high availability and fault tolerance, right? And then efficient resource usage and optimization, and then automated operation, reducing manual work, so faster deployment, right? So, in if I tell you what are the benefits, so service discovery, containers binding it automatically, so the bunch of cluster of containers, the binding automatically, and then distribute the traffic across containers. Let's say you have bulk containers, then orchestration will do load balancing traffic among these containers, and then auto scaling, adjusting container count based on demand. Let's say you have high demand in the one of the afternoon hours, then it will generate more count, more containers at that time. And when it's a nighttime pole, so in the morning, so less demand is there, so it will reduce number of count, so number of containers for the demanding on the on based on demand of the workload, and then has monitoring. So there's a dashboard, check the health container status continuously. If something goes to unhealthy, so it will remove from the group, or it will restart the container, or might be add more containers. So deploy new versions without downtime. So rolling update you can do without downtime, because there are few of containers running the same application. So then more better resource management, CPU, memory allocation, and optimization, right? Um, so if I go back now into the picture, you might have a get an idea. So the container, we know the container now. Once you orchestrate the container, that will make that easier. So here the orchestrator, so developer here, it's a developer here, and then he got a GitHub, and then he got a code in there, then repository. So he manage the code here, and then trigger orchestration, and then you deploy containers. So they scale up or down accordingly. And here then you can do update process, and the monitoring dashboard will monitor the health. See that, so container one healthy, container two healthy, three is warning, so it will take action string three, might restart the container, or get one of the other container instance running. So whatever the it will orchestrator will do the job for that, right? So here we got a three different services: Kubernetes, industry standard orchestration platform. So this is that managing microservice with the containers, and then simple and lightweight solution for normal Docker. And then ECS is a native container service. Containers coming up with orchestration and all other facilities. It's a AWS ECS service, which we're going to discuss more about, right? All right, so we're just going to talk a bit more about containers, ECS, and even the Dockers. We're going to talk. So, introduction to ECS, right? So, uh, that is a container service which is provided by AWS. So, AWS, this AWS solution for elastic containers, right? So, launch type and deployment options. So, you got a few different deployment options provided by AWS. So, the first one is containers on a cluster, easy to instance, you manage. So we can run our own, providing full control over underlying infrastructure, so you can control everything whatever you want. So this method is good for if you want more control over uh, the instances you do. And then Fargate is serverless, so you don't manage them. So it will be provided by AWS. So pay only resources used, so you don't need that overhead. So they're going to use, you can use Fargate solution, and then the ECS anywhere. The extend ECS to on-premise data centers and cloud environment for hybrid deployment. So let's say you run some of your containers in your on-premises, and part of them are running in the cloud, the hybrid, right? And then Windows container support. So basically the the containers running in the Linux, you're getting a containerized application for Windows based, right? That's support. right? And here is a given AWS container options by layer, various layers, right? Um, so let's talk about what is Amazon Elastic Container Service, right? So it's a container service. This is what we're going to discuss more. So ECS is highly scalable, high performance container orchestration service. So we know what the container. Now this is a container orchestration service. It's a service with the other facilities for Docker containers. So Docker containers will be managed by orchestration service, container orchestration service that help you easily deploy, manage, and scale containerized application. So deploy containerized application with minimal configuration, and then you manage lifecycle, resource allocation, scale, and everything. So ECS eliminate need to install, operate, and scale your own cluster management infrastructure, making it ideal for AWS certified solution architect associate candidates to understand container workload scenarios. So this is if you can use your Dockers, you can install Dockers in your desktop, and then you can make more Dockers, and you can use orchestration. So it's all manual, but easy as Elastic Container Service will be a one solution for everything coming up together. So you can use Docker containerize, and then you can use orchestration service to manage them. So this is a key features. So automatic container discovery, and then registration within your VPC, right? And then if you're looking into load balancing, for orchestration service with distribute the load among all these containers. So load balancing service, and then health monitoring. So those clusters or number of containers monitors containers health, automatically restart unhealthy containers. So auto scaling, scaling horizontally based on CPU memory or custom matrix. So you can set up configuration conditions, can make it when you demand high, you can get more number of containers according to the workload demand, and then you can cut off them when you don't need less demanding workload. So, and also persistent storage integration. So EBS volumes and EFS can be used for storage solution for ECS. So keep in mind also that might come up with the questions. So cloud and on-premises run containerized workload both in AWS cloud and on-premises ECS anywhere. That's the solution. And then integration. So this one can be integrations, the ECR, Elastic Container Registry. We're going to talk about that as well in a future video. ECR registry, where we keep the images, container registry, IAM, identity and access management. So ELB, Elastic Load Balancing, CloudWatch, log management, and then enabling enhanced security features and optional best practice, right? So let's discuss some more about details about the Docker versus ECS, EKS. So understanding the difference. So Docker is the most simple container. So quick comparison. So here says Docker is for deployment and testing, and then the ECS is simple AWS deployment with orchestration Dockers, and then EKS is complex microservices, right? So see that Docker is a containerization platform for packaging and application with dependencies. So Docker come up with whatever you need, right? In everything, whatever you need. It's just like coding, uh, coding libraries, right? And dependencies, they come up with that. And then this is ECS. ECS is a orchestration platform. So service for Docker containers. So AWS container orchestration service for running Docker containers. So Docker's managing cluster of Dockers. How do you manage with ECS Docker orchestration service? So developers logging into GitHub, their GitHub account, and then they build Docker coding and everything, and then they apply to Amazon Elastic Container Service. Once you apply that, so auto scaling group, auto scale uh, number of containers for identical containers. So they will create number of containers depending on how much workload demand coming up. When a demanding high, it will get more instances, and when demanding low, it will cut off some of the instances. And then we're not going to talk about Kubernetes now, but as manage Kubernetes service for complex container orchestration. So you have some more complex deployment, so that when EKS Elastic Kubernetes services will come up. So it's included ECR and all other some sort of different services. We just have to talk about this one in a separate video, right? So it's only I brought this one to make sure get an idea of comparison in between three of them: Docker container, so ECS and EKS, right? All right. So still we are discussing and to identify some of the things on the container. So what is a Docker container? So Docker is the building block of EKS and ECS, right? So what are the Docker? We'll have a look. What is the definitions of Docker? Containers are lightweight, portable, self-contained unit that package applications together with all their dependencies, libraries, and configuration files. So everything coming up within it together, right? This is something coming up with it together. Docker, let's have a look. Something like a caravan. You come up with everything, whatever you want. You have a bed, right? You can a kitchen, something like so smaller Docker. So it's portable. You can go into a different location, right? And use that. You sleep there in the bed, and then you can convert it into a chair, something like that. So the Dockers are lightweight, portable, self-contained units package together everything, your dependencies, your libraries, right? So what are the key benefits? Key benefits are portability. So you can go anywhere. So you hire a caravan and you put everything together inside. You got necessary stuff for making your lunches, making your dinners, and then you drive that. And once the night comes, you sleep there. Or something like portable unit, right? And then consistency, so same behavior across environment. So the same caravan, you go in one place, bring go into another 100 kilometers away, and then the same caravan, you have the same thing. So isolation applications don't interfere. So it's something like that. So it's a separate. It's not interfere something else. So I need a more memory. I need a more space. So not like that. So applications isolate the work independently, and then efficiency. So share with kernel resources. So instead of sharing all these hardware resources like a VM, this what this does, it gives OS kernel resource sharing, right? And then scalability. Scalability is quick startup and scaling. So it's seconds when you're starting up, when you're restarting a container. It take only seconds, but if you restart a virtual machine in a minute, so and scaling the other one. So in a dashboard EKS, you can see if you have a 5 containers, so you can see each container healthy. If it's one of them not healthy, it will restart without interfering to service because all other four containers are still running with the service. So just like a shipping container that is standardized cargo transport, so Docker containers provide the standardized way package and run applications across different environment, right? So what's actually inside the container? So what is in one of these containers? You can think of, okay, so you have application code, right? Like let's say you have a .NET code or Java code, and then runtime environment. So you have .NET environment or Java running environment, right? JRE or JDK or whatever the runtime environment is there already. And then your system libraries, the libraries, you need to run them. So something like you can see, so when you're running some DLL is not bound, this library is not bound, sort of, you know, to run some of the command, you need to link to those libraries. So all these libraries to run your code is there, and then you have a configuration file. So how does it run? So that is how shipping container analogy. Uh, I mean, shipping container. What do you have? One of the container, right? So if you're looking into aspects again, so containers are lightweight, startup time seconds, and OS sharing is shared kernel. Uh, then virtual machines are heavy resource, and then startup time is minute, and each virtual machine you have to run a full OS per VM. So relationship to ECS. So Amazon ECS is service that orchestration platform that manage, schedule, scale Docker containers across AWS infrastructure, providing enterprise-grade container management. So what does ECS do? ECS manage these Dockers according to your requirement. It does use a lot of things inside. You have to do the scaling, configuring, right, automatic scheduling, right, and scaling all this stuff in a ECS. That's what the service providers you uh, handy tool orchestration to manage these Docker containers, right? So that is what relationship to ECS to e Dockers, right? I think we have gone up to about nearly 30 minutes. So what I'm going to do, I'm going to stop it here and going to go the rest of video from next video. Until then, thank you very much.